Okay, guys. Today's Friday, October the 30th. We're going to write notes again today over motion graph, but the different kind. So today you're going to make sure to write the date on your notes and title it. So I might ask you for these notes for a grade next week. You're going to be writing some different types of scenarios in graphs and make sure you have an explanation for each graph that you draw. So we're going to learn about two different graphs. You learned about distance time graph yesterday. Okay, sometimes they call it displacement time graph. But today we're going to talk about speed time graphs. So speed is going to be the y-axis. Okay, and sometimes you see it as velocity time graph. Quick recap from yesterday. When we're talking about distance, distance is on the y-axis. Um, we have the y-axis distance here, and then the time as we go along, time on the bottom, and as this line is going further up, okay, if this is our starting point, as we go through time, this could be minutes, seconds, whatever, it because this is going up, we're getting further and further away from our destination. Okay, and there's you can tell that they're going, they started off kind of slow and then they got a little faster, and because this line is straight, that means there's a constant. So they're going at a constant speed, and then they start slowing down. And then this is another straight line, so it's a constant. But because they're staying at the same distance, that means they're not moving anymore. They're not going anywhere. They stopped. So yesterday, we had distance on the y and time on the x. Okay? And I want to call your attention to the pyramid that you guys took notes on earlier this week. Okay? Distance over time graph. That's what we were looking at yesterday. That's what you were writing notes about yesterday. And what does that tell us? That tells us the speed, distance over time, y-axis, x-axis, distance over time, distance over time. Okay, so what is this slope really telling us? What is this line really telling us? It's telling us the speed of something. Okay, that slope on a distance time graph, that slope is telling us the speed. Okay, now for a speed time graph, we have speed. Now we're switching over, it's different now, okay? So we're starting our notes right now, different type of graph, okay? So draw a line, separate, make sure this is completely different notes from yesterday. This is speed time graph. Speed is gonna be on the y-axis now, okay? Speed. A speed versus time graph can be used to determine if an object is speeding up. This is important, write it down. Speeding up, slowing down, or moving at a constant speed. What this graph is really going to tell us, because this is telling us the speed over time, if there's acceleration. And if you guys remember from notes, acceleration is speeding up, slowing down, starting, stopping, or changing direction. Any type of change, that's acceleration. Slowing down is acceleration. Okay. So this is already showing us the speed, okay, because the y-axis, that's the label for speed. So over time, this line right here, if it goes straight across, it's just telling us that over time, this person is going that certain speed. At this point, going that certain speed. At this point, still going that certain speed. Okay? That's what this is telling us. The graph shows us the speed. Okay? So the slope for a speed time graph is showing us acceleration. Is there any acceleration happening here? Speeding up, slowing down, coming to a stop, starting? No, there's no acceleration here. It is a constant. Okay. The slope shows acceleration. On a speed time graph, it shows acceleration. Okay. Is there acceleration here? Is there any change? So let's look at this. Over a period of time, is the speed changing? Well, they started off at this lowest speed, and as time goes on, The speed is getting higher and higher and higher. So by the time we get to over here at this point in time, the speed is higher than it was over here. So there is acceleration. Okay, so this graph is showing us positive acceleration, positive that it's speeding up, it's going faster. Okay, Clara leaves her house and runs to her friend's house. She wants to see how fast she can make it, so she times herself using a stopwatch. If her friend lives 780 meters away and it takes her exactly 260 seconds to run there, what was her speed? So speed is defined as a rate at which something or someone is moving. You can find Clara's speed by dividing the distance that she ran by the time. Okay, and this distance over time is going to tell us the speed. Okay, so on our y-axis, we have speed. So just a refresher on what speed is. Horizontal axis, it's going to be our time. Okay, don't look at these graphs and think of them as a picture of a moving object. Instead, think of them as the record of an object's velocity. Remember, velocity is speed with direction. In these graphs, higher means faster, not farther. So yesterday's higher meant farther because it was distance. But on this graph, because it goes, whatever is higher up here, it means faster. It's the speed. So if there was a line on 0, there's no speed at all. That means they're staying at rest. Okay. The 3 lines below have a different slope. Okay, remember speed or velocity time graph shows acceleration. The graph with the steepest slope experiences the greatest rate of change. Change, that's acceleration. That object has the greatest acceleration. Okay, so they all 3 started out at this one point here, but because this slope, we're talking about velocity or speed, okay, because this slope is steeper, that means in a certain point in time, like if we looked at 5 seconds, this is seconds here, okay, because this is a speed graph, this one is at a higher speed, so they were going faster. If we looked at this line here at 5 seconds, they weren't as fast, okay. Slope is acceleration. The y-intercept, or the y-axis, is the initial speed, or the starting speed. I'm just talking about right here, this line here, wherever they started at, because it's 0 point in time, and then as time goes on. A straight line implies a constant acceleration. Constant meaning it doesn't change. That's what constant means. There's no change. Okay? And a curved line implies non-constant. Okay? A curve on a graph can be a straight or an actual curvy line. But that's what in math, that's the term they use, curved. One way to represent the motion of an object is by using a speed versus time graph. Okay, it's a way to represent motion. In this type of graph, the speed of the object is plotted on the y, speed, and time is on the x. Since Clara was running at a constant speed, a graph of her speed versus time would look like this if she was running at a constant speed to her friend's house. On a speed time graph, the slope of the line corresponds with the acceleration. So they started off going at a certain speed, and as time went on, they got faster and faster and faster and faster and faster. That's what this one represents. This one is they started off super fast, and as they went on, they got slower and slower and slower. Okay? It seems like this one might be the more realistic one since we start off with all this energy and then we get really, really tired. The slope, we're talking about the line, the slope of a line on a graph tells you how quickly the quantity being graphed is either increasing or decreasing. A line that increases as it goes to the right, like going up a hill, has a positive. So we call this a positive slope. Okay, while the line decreases, okay, we call it a negative slope. Objects that are accelerating or speeding up, remember accelerating also means slowing down, but in this case it's speeding up, okay, will have a positive slope, speeding up. Objects that are accelerating or slowing down will have a negative slope. You can also identify when an object has a larger or smaller acceleration by using this type of graph. If the line is steep, that means there is a larger acceleration. They're speeding up way more here than here. It's a slower speed. Slower speeding up. A slower rate of speeding up. This is a faster rate of speeding up. Okay, that's what that means by a large acceleration or a smaller acceleration. Okay, so let's look at this graph here. We have speed on the y, time on the x. Okay, so we're starting off here at the speed. Okay, and I'm going to read this. She moved at one speed at first. She's just going a certain speed and then stopped for a while. So then it drops to 0. Okay, and then she went back towards the origin at a slower speed. So when she started up again, it was at a slower speed. So these graphs look a lot different than distance time graphs. Increasing and decreasing acceleration, not at a constant rate. So here we have over time, we're at a low speed, but they're getting faster at a pretty decent rate, and then all of a sudden they get really fast. Okay, because over a short period of time, they got really, really fast. It went way up the speed axis. Then we have this one where they're starting off pretty fast. Okay, if you look at time-wise, they're going faster and faster and faster and faster and faster and faster, and then they got here and they probably got tired and they started slowing down. Okay, so this is just a recap of some of the terms that we used. So go ahead and pause this and make sure you're writing this down. Thank you for watching and thank you for writing down your notes, guys.